What if I told you that somewhere beyond our solar system, there are worlds that look enough like Earth to make scientists stop and ask one of humanity's biggest questions? Are we really alone? And here's the strange part. We have already found thousands of planets orbiting other stars. But finding a planet that is similar to Earth is much harder than simply finding a planet that is the same size. Because Earth is not special just because it is rocky. It has an atmosphere, liquid water, a stable climate, the right chemistry, and a star that has allowed those conditions to persist for billions of years. So when scientists call another world Earth-like, they are usually talking about some combination of size, composition, temperature, and location, not proof that it has oceans, forests, or life. And that distinction changes everything. Let's start with a world that completely changed the search for Earth's cosmic relatives. Kepler 186f. Discovered in 2014, Kepler 186f was the first Earth-sized planet discovered in the habitable zone of another star. It is about 1.17 times Earth's radius and orbits its star every 129.9 days. That sounds promising, but there is a catch. Its star is a red dwarf, much cooler and dimmer than our Sun, and we still do not know whether Kepler 186f has an atmosphere or liquid water. So despite its reputation as an Earth twin, calling it another Earth would be going too far. And that brings us to the first controversial truth about these worlds. The phrase Earth-like planet can sound far more certain than the science actually is. Now, imagine finding not one Earth-sized world, but 7. That is exactly what happened with TRAPPIST-1. About 40 light-years away, astronomers discovered 7 rocky, Earth-sized planets orbiting a tiny red dwarf star. 3 of them, TRAPPIST-1e, F, and G, are located in the star's traditional habitable zone, where conditions could potentially allow liquid water on a surface. 7 rocky planets, 1 star, and several candidates in the Goldilocks zone. For a moment, this looked almost too good to be true. But space has a way of ruining simple stories. These planets orbit extremely close to their star. They are also likely tidally locked, meaning one side may permanently face the star while the other faces away. And their star is active. Powerful stellar flares can bombard planets with radiation and potentially erode their atmospheres. Then came another reality check from the James Webb Space Telescope. In 2025, Webb observations of TRAPPIST-1d found no clear evidence of an Earth-like atmosphere. Scientists did not detect atmospheric signatures of water, methane, or carbon dioxide in those observations. That does not mean the planet is definitely lifeless. It means something more important. We have to be careful about what we claim to know. TRAPPIST-1d may have an extremely thin atmosphere. It could have clouds that complicate observations, or it could be a barren world. Scientists are still investigating. And if that sounds disappointing, it shouldn't. Because ruling out possibilities is part of how science moves forward. Now consider another intriguing world, TOI 700d. This planet is about 1.07 times Earth's radius and has an estimated mass around 1.25 times Earth's. It completes an orbit around its red dwarf star in about 37.4 Earth days. Most importantly, it receives enough stellar energy to place it within its star's habitable zone. That sounds exciting. But again, habitable does not mean inhabited. The habitable zone is simply the region where liquid surface water could theoretically exist under suitable atmospheric conditions. Earth's moon is inside the sun's habitable zone too, and it has no known life. So the Goldilocks zone is not a cosmic life detector. It is only a starting point. And there is another candidate that scientists are watching closely, TOI 700e. Unlike TOI 700d, this world is closer to Earth in size, but is not simply a copy of our planet. It is part of a fascinating system containing multiple small planets, giving astronomers a rare opportunity to compare worlds around the same star. Then there is Proxima Centauri b. It orbits the closest known star to our Sun, only about 4.2 light-years away. That makes it incredibly interesting. But being close to us does not make it Earth 2.0. Proxima Centauri is a red dwarf, and its planet orbits extremely close to the star. Stellar activity could make conditions on the planet challenging, and scientists still do not know whether it possesses a protective atmosphere. In other words, the nearest potentially habitable planet may be nearby on a cosmic scale, but still completely alien. And here is where the story gets even more fascinating. Scientists are not only looking for planets that resemble Earth from the outside. They are beginning to examine their atmospheres. This is where the James Webb Space Telescope becomes a powerful detective. When a planet passes in front of its star, a tiny amount of starlight can pass through the planet's atmosphere. Different molecules absorb different wavelengths of light. That leaves fingerprints. Water vapor has one pattern. Carbon dioxide has another. Methane has another. By studying those fingerprints, astronomers can begin asking what these distant atmospheres are made of. But there is a huge problem. These planets are incredibly faint compared with their stars. It is like trying to identify a tiny firefly flying directly in front of a gigantic searchlight from thousands of kilometers away. That is why detecting an Earth-like atmosphere is enormously difficult. And even if scientists find water vapor, oxygen, methane, or another potentially interesting molecule, that still would not automatically mean life exists. This is perhaps the biggest misunderstanding in the search for extraterrestrial life. A potentially habitable planet is not the same thing as an inhabited planet. An Earth-sized planet is not necessarily Earth-like, and a molecule associated with life is not necessarily proof of life. Scientists have to consider geological and chemical processes that can produce similar signals without biology. So where does that leave us? Surprisingly, in a very exciting place. We now know that rocky planets around other stars are real. We know that Earth-sized worlds exist. We know that some orbit within habitable zones. And we know that planetary systems can look dramatically different from our own. NASA estimates that there could be billions of terrestrial planets across the Milky Way, but we still have no confirmed evidence of life beyond Earth. That sentence may sound disappointing. Actually, it may be the most exciting sentence in astronomy, because the search is still open. Every new telescope observation can eliminate one possibility, strengthen another, or reveal something nobody expected. Maybe Earth-like worlds are common. Maybe truly Earth-like environments are extremely rare. Or perhaps life can survive in environments that look nothing like Earth. We simply do not know yet. And that is why these distant planets matter. We are not just searching for another Earth. We are trying to understand what makes a planet become Earth-like in the first place. So the next time you look at the night sky, remember this. Some of those tiny points of light may have planets orbiting them. Some may be rocky. Some may have atmospheres. Some may have water. And somewhere out there may even be a world that has been waiting billions of years for us to discover it. If you enjoy exploring the biggest mysteries in science and space, follow for more. But now I want to know what you think. If scientists discovered a planet that was almost identical to Earth, would you want to know whether life exists there, or would you rather never find out?